Okay, so for activity 34, we are looking at what we call the phase shift. The format for this, we have y equals sine x minus c. Now I want you to notice that this is inside the parentheses. We've seen this before with other types of functions. Um, so this is also, you can think of as the horizontal shift, which you probably would have guessed. So now notice that we have y equals a, sine b. The b is going to be outside the parentheses, x minus c plus d. This is all put together. Now this part is the horizontal shift, which is the phase shift. This is the vertical shift. We haven't always called those C and D. In the past with other types of equations, we've called that H and K. Well, we're not going to use H and K, but it's kind of the same thing. So that, the H, which we normally had as the horizontal shift, now we're calling C. Remember that it was opposite the direction of the sine, and this one was the same as the direction of the sine. Those things are still going to be, the same type of thing. So what you're going to look at when you're graphing this, here's my parent graph. The value of C, there's nothing added or subtracted, so it's 0. And the phase shift, it didn't move left or right, so it's 0. And then they ask you this question, what are the x-intercepts between 0 and 2 pi? So there's this one, and there's this one. Because we're going to use these x-intercepts as locator points when we graph a sine curve. As a matter of fact, there are 5 locator points. The beginning of a period, the end of the period, the middle of the period, halfway in between those, which is the maximum, halfway in between those. So those are going to be our 5 locator points. So they're asking you about those intercepts. So on this next problem, so you'll see I have the parent graph, then they have the next one. If I go ahead and graph both of them, here's the parent graph, and then here's what happens when I shift it over. You can see the min and the max didn't change, the amplitude didn't change because I didn't change those. I didn't move it up or down. All we did, we only had one thing that changed, and that was the phase shift. So the value of C in this case is going to be pi over 4, because we have x minus pi over 4. And if we take a look at the graph, so here's my graph. Now, be careful not to look at it and say, oh, maybe we moved it down. Remember, we just moved it to the right pi over 4. So notice how it was on the x, one of the x-intercepts was 0. Well, now I have an x-intercept, and when you're trying to think about, well, what is this value? Remember that this is 0, this is 2 pi, which means this is pi over 2, where the tick marks are. We counted by pi over 2's. Well, this is halfway between 0 and pi over 2. We also know that we moved it over pi over 4. So instead of being at 0, it moved to the right, pi over 4. So then we have another x-intercept right here, and you have to try and figure out, well, what is that? We'll count by pi over 4's. So if the first dot that I plotted there was pi over 4, that's 1, or do it this way. At pi, we had an x-intercept. So you're going to do, what is pi plus pi over 4? Because it's moving pi over 4 to the right. If you find a common denominator, then you get 5 pi over 4. This is going to be the hardest part of the whole thing. And that's because you have to add with fractions. Because when we're dealing with radians, we always have fractions, got to find your common denominator. But come on, you guys, you're in college algebra and trig, you can handle that. I only have 2 of them. Remember it said x-intercepts between 0 and 2 pi? Well, if I do 2 pi plus pi over 4, that's going to be larger than 2 pi. So I only have these 2. That's what you're going to do. Oh, the phase shift is pi over 4. Now, if you want, I like to put the direction, pi over 4 to the right, because that's meaningful. We kind of thought of that when we did horizontal shift. Did it shift to the right or to the left? So that's what you're going to do on this set of activities, and then you'll have this, and you'll be thinking, now we're only dealing with phase shift. We're not putting it all together yet. That's going to come in the next activity. And then you have some questions to answer about the phase shift.